Welcome and thank you for listen to this video and watch this video and the past broadcast probably. And today I would like to trying to implement this difficult part. I would say this is kind of difficult since collision is one of those topics which is uh, has it's some mathematics in there, but uh, there are well-known algorithms to do this to make this type of implementation, the code. Um, and uh, and yeah, I will try to make this possible in the this custom render we are doing. And I will try to bring some ideas because I was thinking how to implement this thing in I mean with different approaches. And I thought one of the possibilities is to use AABB approach. Is this classic type of collisions detection, which is based on a bounding box, and um, and yeah, to make this possible, I need to modify several things in the render right now. Actually, for saying that it's different things is not exactly accurate because um, I just need to touch in the specific parts because we already have some maps in the game. I mean, handle maps, at least the proof of concept because it's not yet complete. When I'm trying to say this, it's not complete because we will need to see how this is going to behave with a bigger map, right? We just have a very simple map. But I think we are in this part where we can have collision and we can start making collisions. And I already have some code just for me to help to guide me where I need to touch in the code, and just to have a glimpse where we are. This is the current state of our render and of course our possible game. Right now we can move through the world, having some animations. We already make this idle animation based on the previous direction of the velocity, right? In previous broadcasts, I already code how to how to have this direction in in the state of idle state. If you remember, if I move to idle state right now, kinematic idle state here. Let me check if you are seeing something. Yes, you are seeing something according to OBS. Um, and then here in the idle state, I can show you guys in the previous video. I was working exactly here. Yes, here. Uh, here. Uh, getting the velocity, we can normalize that velocity to have the direction. Actually, yeah, this is the only part of the velocity we need because we don't need the speed, but the direction of that speed, right? It's the concept of velocity. And here we have implement just the idle right. If you remember, guys, we need to implement the idle left, idle up, and so on. But for this, it's enough for a proof of concept. So it's easy from this point. It's easy to leverage the further animations. So I am happy with the state. I can do it later. I mean, complete all these things because actually we also need to code the diagonal direction, right? And what else? we need to we need to see in yeah in the we need to check in the round state here where we are here in player control system. We make this code to try to have some way to remember the direction of the velocity, right? Because in the moment we were using this in the animation system, but we also need it in the movement system, and so that was almost the state of the of our custom render right now. Okay, so there is of course there are a lot of to dos to make. This is one of those, but yeah, we will not continue through this path. We will do in some collisions if possible. Okay, so first we will need to make visible the tiles, the tile program, right? This program I'm using to make the maps. So let me add, guys, a a window for that. Just a moment. Yep, that is what I need. So, guys, yes, here is the map we have in the game right now. Uh, and using this tile set, this proof. Uh, yeah, because we just need some images right now, and we will use the final texture in the future. Anyway, this program, guys, also have the possibility to make objects, and we can have those objects as colliders. And I have already done some tests here. As you can see, I have some kind of square, like dashes square. Um, and this is for me the collider. I will use this. There are two approaches here, guys, in this program to make this possible, and I think I will use at least for the maps. I will use the approach where I can have a bigger object, name it collider. It's a bigger collider that covers several tile set of the map instead of having one single one single object for each collider. And how is this exactly? Well, if you see here in the tile set, you can edit this tile set and you can put some objects per tile here per tile per tile, sorry. And by doing this, when you use the the editor of the map, when you put a tile that you already put some object here, so you can the program also knows that tile has an object, so it's easier for you to put an object because the tile already has the object itself, right? But what I what I don't like about that approach is that you will have several elements of colliders, and that's why I will iterate the program in C++ will need to iterate through all that elements, and so I think it's not then effect yeah, effective will be, but efficient not too much. Okay, so the other approach is to make those square, but in the object layers. So you can have object layers here, and you can draw some objects as you do with layers, normal layers, let's say. And so this is a way to do it, but of course you have to do it per. Uh, you have to do it for all on the whole map, right? So when you put some more tiles in the map, you will see that you don't have this object, not like this. So you will need to put it again, I mean by hand. But I think this is more accurate because I can have one only object here, one single object, or two in this case, and these bigger objects will allow me um, to make colliders bigger, and this is just two elements instead of several elements. So that's why I think it's better approach. Anyway, in any case, in having decided an average actually, because that will depend, I need to serialize this to make to make this file readable for C++. Right? Remember, remember is since this is a file based on JSON. This JSON is a crate, let's say a crate readable human readable file to understand what is going on in the structure of the data, but it's not that efficient for C++ or for any program because the most efficient way to read the file for a program is a binary file. So there is a process of serialization in any engine that you use to to make the to make the the readability of the file better for the code. And we already did something like that in C++ by having this by having a serialization process for the map. I mean for the tile set. And what we need to do is to make something similar, but for the objects. So if we study the anatomy of the architecture of the JSON file of a tile file that have object layer, we will discover. Let me look. Let me search for it, guys. Um, yes, this one. This is the ground layer, as you may have seen in the tile program. And this is the object layer that had two elements or two colliders in this case. I had named collider with some properties. So I need to read this layer and kind of relate this layer with this layer. Here I'm using a relationship between layers based on the name. So I decide to make ground and cold ground like siblings, but this is in charge of the colliders of the maps, and this is the in charge of the tiles textures in the map, right? That is the point. Um, so yeah, that means I need to modify the Python code that does this serialization, and also I need to make more structures in the theme file in the yeah in the level file reader to make this to read to have this information about colliders. So let's start for that part. I already have some code there, so it will be better if no, not this one. Level reader. Let me check. No. Mm, sorry. There we go. Here. Yeah, these are the structures that I use to load the the serialized files of the tile. I mean, there is a Python part that I need to also to make some arrangement there, but this is the part of C++. Here I have already some structures that I was just putting here to remember what was in my mind in that moment. And I have already a TMF collider, which is which will be the collider we will have here, right? So for this map, we will have two elements, or two colliders, and this information, the information that this collider have, will be stored here. By now, I was just taking the minimum attributes that I need to make a collider, which is the corners, the minimum, the bottom left corner and the top right corner, right? Because I just need 2 points to make a square, a bounding box. And yeah, I think with this, I can derive a collision layer, which will be the code layer I have in the TMF file. I will try to arrange, guys, to have the two datas PM file here. We'll collapse this and this. So yeah, I have, sorry, here. There is, there is it here. Okay, now it's better. I will have a collision layer. I was saying, yeah, it's a collision layer which has colliders. So I will, I will take this information from gold ground and put it in here. As you can see, I have a list of objects here, so I will need a pointer to make a list or an array in memory to store all this information. Uh, for now, that is the strategy I was thinking of. Okay, because maybe this could change in the future to make this more efficient. But by now, I will do it in that way. Okay, let's uh, let's continue doing this in the code. Um, to make a binary a binary uh, read strategy, I need some information in advance to know what is going on in the future, right? That's why I have a header here, a header. This this thing is give me some information about the next or the data I will find in the future. For instance, I have the number of layers I will have in the map. In this case, I have, let's say, I count number of layer here. Um, and also I have the number of tile set because of course a map can have textures from different tile sets. And what I also what I need right now, in addition of that, I need a collision layer as well. So how I managed to say uh, now beside team number of layer, we also have number of collision layers. But with the with having in mind that you likely um, you will not have the same amount of layer as number of layers. As number of the same number of collision layers as normal layers. That is the thing we will need to think about. Hmm. Yeah. Okay. Hmm. Well, I think I think I can have a number of collision layers I will need to have uh, some methodology here based on the position of the layers in the JSON. But of course, having just one number here, um, doesn't represent what is actually the data in the future. So yeah, I can. List of layers. I can have a small portion that said wait, this is a collision and this is a tile set layer. I can have something in the binary stream, and we will always storage the things sequentially in pairs. So if one tile set layer doesn't have a collision counterpart, so that means it's a layer with no collision, with no colliders. So if I want to make some collision in the foreground, I will put another up another collision layer called foreground and put it in here. There you go. And when I save this, I will check the file and let me check. Yeah, as you can see, guys, the order is important in this case. So the next layer after a tile set layer will be the collision layer. Yeah, I think that could work. But of course, you can have a case where you have a tile set with no collision, so you will don't have anything apart from this. Yeah, but I would like to have that information in advance. But how can I? How can I do it? In a team file, not in the header. Not in the header. I have list of layers, list of tile sets, and a binary string. I can have a list of yeah, list of layers, collision layers, but maybe with the hash map as well, or at least an identifier. I mean, it's for sure we always have something in the collision, in the tile set layer. So if I have a list of collision layers, let me advance that collision layer here. Then TM collision layers. TM collision layer list of layer. I will have a possible one possibility is to have different elements. Yeah, I think we will, guys. Let's Sorry, guys, you are not seeing anything. There you go. I was thinking in making some collision layer uh, here in the TMF file because what I need is to have a at least two lists where this is the list like has priority because we will always have layer with tiles, but not anytime we will have collisions. Of course, we can have an average. We can decide to make an average where we also have colliders in same number of layer of tiles, same number of the same number of colliders, layer of colliders as well. But as you can see, when I have a layer of tile, I have its corresponding collider layer below, because in the tile I put here up of the layer, and the same for foreground, but not for props. That means when we check the test3 TM file, we will have ground, cold ground, foreground, cold foreground, and props with no colliders. So what I want to do is the following. Let's go to our notes. Is I have a list of tiles like this, and I have the layers here like this. Let's remove this from the equation. Yep. So this is tile 1, tile layer 2, tile layer 3. So now I want to have also colliders, and I will have a list of that colliders here like this. So one possibility, one case is to have the same number of colliders as layers here, same number. But and in that case, I will just have a list of anti-colliders, which is not that bad. But other possibility is to have just a different number. Let's say uh, collision layer 1, collision layer 2, or 3, to not make any sequential stuff. And so this is the corresponding for this, and this is corresponding for this, and this doesn't have any. So this is, let's say, a bit more efficient because I don't need any memory for the empty list. But here there is a problem because how I know which tile has uh, which tile has collided. So I was thinking have uh, more attributes in the layer, additional attributes, because right now we have just a list of what we have exactly. Let me check. Let's check here. Colliders. Uh, yeah, I think this is incorrect. This is incorrect. This is incorrect because I want to have a list of colliders in the collision layer. Okay, and when I do this, I will have, yeah, because these are several elements. These are several elements. As you can see here, the ground layer has two colliders right now, but we will have many. So this has to be a list of colliders. So a list of colliders inside a layer, one single layer, and let's suppose this is the ground layer. That's correct. But what happens is if I have another layer with other colliders. So again, I will need a list of layers here to make this possible. Yeah, perfect. So I just say, okay, you also you can have this. You can have this or other or uh, or an empty list of colliders. Hmm. But one possibility is to have here an ID, an ID of the tile layer. So by using this, when I iterate for the through this list, I will check first, or through this list actually. Yeah, it will be this list. Hmm. Maybe maybe it's not even required. That will depend of the tile mask. Maybe I will just need one, but that will depend of the mask of the collision. Ah, yeah, guys, that is another approach. I think we could change everything. Yeah, we could change the approach. What I'm thinking is this: there is a way to implement collision based on a mask. It's actually like mask, binary mask. No, I think it's called bitwise. It's bitwise mice, bitwise masking. This is like having a matrix. I think Unreal Engine, any engine actually has this type of implementation. Is like having a set of elements, same environment, projectiles, and so on. And here's having some also entities. And for instance, when this is check, so the environment or this entity collide with the things in the environment, but not with the project, with the projects, projectiles. Sorry, with no projectiles because it's empty. Um, so let's go further. Yeah, I think this is the way to do it. And I think from here, from the column, I need to check the theory. I don't remember exactly right now, but from the column, we can extract the the bit the bitwise. Yeah, I will check, guys. I will figure out this, but this is the concept. So when an entity, this stuff, or if the entity uh, is part of this set, let's say, the entity will have a mask like this, 001. So with this, uh, we know that the entity will collide with some stuff in the environment. Okay, so this is like part of the component, part of the uh, component set from an entity, I mean. Okay, okay. Um, Now, what is the change I am proposing right now? I am pursuing right now is okay. We have some tiles in the map, and I was thinking, I was thinking use many many collision layers. Let's do it like here. Collision layers, each for each for each one for each layer, one for each layer. In this case is the ground layer, the foreground layer, and props, and so on, right? So the previous approach will be having collision for this, collision for this, collision for this. But I think this is not necessary, guys. This is only we only need one collision layer, and decide to which mask, which mask this collider. Um, if it's a mask that here like this, well, it's collide with everything. Will collide with everything. Would be a collider for everything. So projectiles, also environment. So if a projectile hit the wall, we'll say, yeah, it hit the wall because it has this mask. Okay, yeah, I think would work. Um, yeah, but what happens is if we have the case where we have something like this, guys. Imagine we have a path, nice path here, and we have a bridge here. Sorry, a nice bridge, very rusty bridge here. There we go. Um, so in our 2D game, we will need to make something like this. The character or any NPC will go through or below the map, below the bridge, I mean, here, walking like here, and he will pass, right? But what happens if the entity goes here on the bridge, here, walking here? So the bridge will have colliders here in this part. It will collide here, right? I mean, you cannot jump uh, from the bridge to the path here because there is collision here, meaning that it's a different layers of collision, right? So what else we need to make this possible? Walking here, but when I am on the bridge, I can walk to the edge. Hmm. How can I? How can I do it? Yeah, this is a good thing. besides the mask, I probably would need something else. Hmm. I'm not. I don't know right now. Well, we can have this for the future. Trying to implement something like this because this will be something that we will use in the components anyway. I believe. Yeah. Hmm. Mm, I will figure out. I will figure it out, guys. This thing. Maybe using another element of death. Yeah, based on the death, we collide or not, because having collision based on the layers could be as well. Mm, right now, let's 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 stick to the average of having. Let's stick to to the one single. Sorry, collision layer. Average. Okay, right now. Hmm. I will figure out, guys. This very interesting. So I think we still have this code good. I think this is a good code. At least for the initial idea. And let's try to make this another part, which is the Python part. I will move this here, and I will check. How is the name of this? Level Gen. Hmm, Level Gen. I think it's this one. No, no, I don't. No, this is not the one. Level. No, this is not the code. How is? What is the name of this? Dial Gen. Has to be this one. Serialize button border panel. Now this is for the UI. We need to also do the UI, but not now, not today. Not today. Let me check, guys. Here, level gen. Ah, style gen. Yeah, style gen. I need to clean some code here. But I think it's this one. Yep, yep, yep. It's this one. Perfect. So let's try to modify this serializer based on Python. TMF file factory. Here, I think it's the class. Process layers. Receive a list of layers. Where I use this? Go to final reference. Here. When I do pack, I process the layers. Then the tile sets, and here I should process the colliders from from yeah, one layer at the moment, and then yeah, save similarly of the layers as I believe. Okay, when I process layers, sorry, I have all this information. Yeah, as you can see, it's almost the same here. So I should do this as well. Uh, so let's make a similar function here. Collision layer will be a collision layer here for a call. And this one, um, I think I will need an object for this collision layer as well. Yep, a lot of code I need to refactor, guys, and to put in something in package, better way to make it. But the most important part is try to advance. You know, it's not a good idea to start thinking in details and too much detail in order this the best way possible, because if not, you will lose a lot of time, and maybe the focus of this moment is trying to make more and more and more and more, and then think in refactor and stuff. At least it's the one of the things I have usually do, and it was for me, guys. So if you can use it, you are very welcome. Um, okay, collision layer, similar of a layer. Mm, let's see what else. Nothing else. Okay, let's make exactly the same. Let's use all of this. Let's use this, and also objects. Yeah, here. So erase all of this. Maybe drawer there is not necessary, to be honest. ID, nah, yeah, let's skip it. Let's skip it. Objects, I think objects is not the right, it's not in the right place here. Uh, Objects is has to be another yeah, another class to store all these things. Yeah. Mhm. Let's copy this. class. Guys, if you are wondering why this guy is using Python to make the serializer, because it's easier. It's easier to use a script object, sorry, a script programming language uh, to make things like faster and also to tweak the code in the specific areas and moving on, you know. So that's why I decided to use Python for this type of assets baking, you know. It's the part of the asset baking. And if I will optimize or automatize this this process, I will still keep in Python, you know, because it is Python is not that fast as C++, you know, the languages, but it's kind of versatile, right? So I will, yeah, I think it's the way to use Python to make this type of things for not production ready code. You know, it's of course you can have Python very fast algorithms Python if you use other if you use specific libraries that has the foundation code in C++. For instance, NumPy is heavily based on C++, so it's very fast and very efficient. And yeah, yeah, that's it's also a possibility. There is ways to optimize Python code. But yeah, this is not the channel for this guy. For that kind of topic, you can see in YouTube, and you can find several ways to optimize Python if you like Python. I like Python. I have done several stuff in Python, and it's very nice programming language. But the part doing of being a great software programming is to know the tools or the better tools for the specific task. You know, it's just, yeah, it's the way. Let's say, um, yeah, objects. We will call it objects. Let's call it objects right now. An object is a def init. Uh, this thing can go. There we go. Uh-huh. Um, I think we will need some default values. None type. Yeah, let's skip type. Visible. Yeah, visible. Let's put it true. True. Then we will need some self. There we go. Self. There we go. What else? Mm, nothing else, I believe. Yeah, perfect. So then objects, I think, yeah, let's do this. Let's have some divider here as well. Okay. Well, of course, we will need define the structure. This is the way to define um, to have a C++ or Z, just plain Z, um, a struct to make a struct readable for C++ or probably for any other uh, any other programming language, because this is just binarization of data. Um, yeah, so I think could, it could be convenient to have a struct here as well. Uh, and hmm, we need to have in mind. Let's put in here. No, no, it's not this. I lose it again. Let's put in that. We will need to have in mind that this is the data we expect. Well, I think it's U vector 2 is not, because I will need to keep this pixel perfect. So vector 2 is not the right. It's not the right structure. Maybe vector 2 could be the best, right? Because this is an unsigned, assuming that we are also always in the positive right of the coordinate system. No, yeah, probably this is the best. Okay, let's continue and said, let's store 32, 32. Should we use a 16 bytes? Yeah, Python needs some formatting strings to use. No, Python struct. This class needs formatting stuff, and each character that you see in this string, guys, because this is just characters, as you can see, S, P, V. Each one of those represents a data type, a primitive data type for the struct. So this current format you see here will produce, or will expect to produce, a, a structure with a string b and an integer, which is a unsigned integer, c unsigned integer of 32, and so on, right? So what I'm thinking is how, what the right data, primitive data I need to fulfill this struct in C++. That is what I'm thinking right now. Hmm. Okay, probably, yeah, probably it's just using 32 to 432s. Yep, that is what I need, right? And maybe it's better if we change this trait to as well. So of course you are saying like this is just four primitive and you have several. What is going on? I'm just thinking in the data I need for fulfill this one, and the other I will of course have the class here for all the objects, but I will just serialize what I need right now. Okay. Okay. Let's say let's do a do pack function like the one here. Of course, I will need bytes. Where is bytes in the everything is defined in here. Yeah, Python allows sort of thing. You as you may know. Anyway, we will do it similarly here. It will be self as well. And let's pack. Let's pack what? Okay, this is the minimum. Bottom left, bottom left. This is the maximum. Top right, bottom left. Okay, bottom left refer to this guy. This is bottom left, right? Here, bottom left. And this will be top right. Bottom left, top right. That is the way. That could be the way. Based on the fact that this is our origin of the coordinate system, maybe this could be the proper, the better point to store, which is top left, right? Top left and bottom right. Top left and bottom right. So let's name it like that, right? Top left. Bottom right. Let's name it like that, guys. Top left. Yep. Top left. Maximum corner. Minimum corner. Yeah, based on the origin of the system, it's not exactly maximum or minimum. Let's erase this. It's not a good comment. Anyway, there we go. Mhm. Yeah. So based on that, let me check again, you guys, the way this is stored. 64. What happened if I move this to 12? Oh, okay. 64. Yeah. So indeed, it's based on this point. Except 32, 64. Uh, yep. Yeah. Excellent. Excellent. So top left in do pack will be self X and self Y. Right? See, guys? Yeah. Stay forward, right? Straightforward, right? Remove this. And then width and height. I will need this too. I like to have width first. There you go. It's bottom right. And this has to be, because these are coordinates, like this. Right, guys? Mm-hmm. Good get this. Yeah, it's x from here plus y plus width, sorry, would be this, and y plus height will be this. So the point we move here. Yeah, we are set. Then this store the bytes, and we will use the bytes in the collision layer. Okay, okay, guys, this was the 1 hour. I will code. I will return probably later, but I need to make some dinner. Okay, so thank you very much, guy, for see this broadcast offline probably. I will be very happy if you have any question and you just come to my channels when I am doing streaming and you ask me a question you have for programming. If you are interested in programming, so I will be very happy to answer any question you have, or maybe give you some advice if you want. Also, I can do it. But in any case, I thank you for being interested in my channel, and I will see you guys pretty soon. Bye bye.